about to get hot in here. You know why? Because we're talking about combustion. Combustion's when things burn. So I wanted to do an example of balancing for a combustion reaction. It didn't matter which one specifically, but I picked butane because it's a more challenging one. The combustion reactions can get tough because you have to go back and forth a lot of times. There is actually a quicker way to do it, so I'm going to do it the way I taught you, and then I'm going to show you a little bit of a shortcut to make your life a little easier. Butane is C4H10. It's actually the stuff that's in lighters. Not that you should necessarily be using lighters, except for your birthday cakes. Yeah, so it's okay for you to use lighters, actually. C4H10. So it says balance the equation for the combustion of butane. So we know we have C4H10, and we know for combustion it's always burning with oxygen, and it's always going to produce carbon dioxide and water. And I could put all the phases here, right? This is gas, gas, gas. This could be a liquid or a gas. Let's put liquid. Okay, and so now I'm going to balance this sucker out. Right, so first thing I'm going to do is I'm going to, draw out all the elements. So there's 4 C's, and there's 10 H's in each butane. So you can see why this would be a little tedious, especially if you have to go back and forth a lot, which sometimes you do. 2 O's, put them together because that's one chemical. CO2, or Cu. H2O. Now, always do oxygen last, okay? Even if you're not doing the shortcut, always do oxygen last. So we can do carbon or hydrogen first. Let's do carbon. So there's 4 carbons here. There's only 1 here. So I'm going to add more carbon dioxide to balance out the carbons. So there we go. My carbons are balanced. Now I'm going to balance out the hydrogens. There are 10 here. There's only 2 here. So I'm going to add some more H2O. So now there's 4, 6, 8, 10. Okay, so my carbon's balanced, my hydrogen's balanced. Now I've got to balance my oxygen. There's 2 here, and then on the products I have 2, 4, 6, 8, and then 1, 2, 3, 4, 5. So 5 plus 8 is 13. So this is 2, 4, 6, 8, 10, 12, and I need 13, but I can only add it in 2s, so I've got to add another one. So now I've got 14. Oh, great. So now I have to go back and I have to add more oxygen. Well, I can add the 1 more oxygen that I need to balance it out by adding 1 water. So there I go, there's 1 water. But now my hydrogens aren't balanced, which means I need to add a whole nother one of butane. Which, yeah, that's a lot more hydrogens than I need, but it's the only way for me to add hydrogen, and I can't just add 1, I have to add the butane all together. Well, that means I actually need a lot more waters over here, doesn't it? Right, let's see. I have 20 hydrogens now, and I only have 2, 4, 6, 8, 10, 12. So that means I need 8 more hydrogens, so 4 more waters. So HHO, 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 HHO. Okay, so that should be 10 waters total now, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is 20 hydrogens. So that's balanced. Now let's check the carbons. I need 4 more carbon dioxides. Okay, so all the carbons are balanced now. Now let's count my oxygens. I have over here 2, 4, 6, 8, 10, 12, 14. I'm going to sketch that down so I don't forget. 14 oxygens. And then over here I have 2, 4, 6, 8, 10, 12, 14, 16. So that's 16 from the CO2. And then I remember I have 10 of these and each have 1, so that's 10. So I have 26 oxygens, so I need to add more until I get to 26. So this would be 16, 18, 20, 22, 24, 26. Okay, and everything's balanced. So I have 2 butanes. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 oxygens. I have 1, 2, 3, 4, 5, 6, 7, 8 carbon dioxides, and I have 10 waters. And that's the lowest whole number ratio because 13 is a prime, so I can't divide that all by something, so I know I didn't make a mistake. And that'll work. Okay, yes, it took 5 minutes, but that'll work. So here's a way to do it a little bit quicker. Not a lot quicker, but a little bit. So we still start with C4H10 plus O2 gives us CO2 plus H2O. And we're going to do the same thing we did until we get to the oxygen part. Then we're going to do something a little differently. Okay? So let me just kind of save us some time and just do some copy pasting here. Okay. And then we had 4 CO2s. Okay, we had, what was it, 5 H2Os? Yeah, that's right. We had 5 H2Os. Okay, so now here's what we're going to do. We're going to figure out how many oxygens we need. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 oxygens. 13 oxygens. Now each O2, there are 2 of them. So that means if I do the division here, I would need, which isn't possible, but I would need 6.5 oxygens, right? Because each one's 2, so 2 times 6.5 is 13. Now that's not possible. You can't have half a molecule of oxygen. So what I'm going to do is I'm going to take the coefficients that I currently have, I'm just going to multiply them all by 2 so that this becomes a whole number. Right? So if I multiply these all by 2, well, what do I get? I get 2 butanes, I get 13 oxygens, I get 8 carbon dioxides, and I get 10 H2Os. I know it's still balanced because I didn't change any of the ratios. Right? This is still a 1 to 6.5 ratio. 2 to 13 is the same thing. Right? 4 to 5, 8 to 10, that's the same ratio. I just upped it by a factor of 2. Okay? So, a little quicker way to do combustion reactions, which are really the only ones that'll take you a lot longer. All the others, even the ones with polyatomics, doesn't take that long to do it this way. And even this one you can do in 5 minutes as long as you don't stop and say, oh, I must be doing something wrong. As long as you don't whine about it, you can still do it in 5 minutes. I did. But this you can do in maybe 2 minutes, even for something with really nasty coefficients like 13. Alright? So I hope you had a beautiful time with me here. Look at all this red. Luxurious. It's like the red carpet of balancing equations. I have no idea. I'll see you in class. Bye-bye.